All right. Now we have the more difficult problem. We don't have symmetry, and so we have to use both our x and our y equations. We have to set them up. And so the first thing is to draw the forces. And I haven't even bothered to draw the strings or whatever. We're dealing with a situation kind of like this. I'm just drawing the forces. And I know from experience that this cable here, okay, that our viewers at home can't see, okay, this cable right here, the one that's more straight up and down, has more tension in it. This one has less. You can see that, okay? So I'm drawing this guy, as a longer tension, this one as a less tension like that. Right? And then, of course, gravity will be straight down. All right. And so I guess we need to figure out the force. 12.5 times 9.81. 122.625, is that what it is?
Yeah.
All right. And then there's this one, and then these angles here. This is a 20-degree angle, like that. This guy here is a 40-degree angle. Okay. So I've drawn all the forces. Now I need to draw the components on there. So the components of this guy, and here you can see whether you drew the thing correctly, right? If this is T3, then this is T3 sine 20. This one here is T3 cos 20. Right? And then this line here, I know this guy's going to be congruent, right? So it's like, so I drew that guy a little bit too long. Okay. So this is going to be, if this is T2, this guy here is T2 cos 40, sorry. Okay, and then this component here, there we go, right? This one here is T2 sine 40. And again, I'm just using SOHCAHTOA. The opposite side from the angle is sine. The adjacent side is cosine. Opposite side is sine. Adjacent side is cosine, like that. And then I know also, if I want to be real picky, first off, these guys are going to be equal, aren't they? In the x direction, equal but opposite. Don't they have to be to cancel each other out? Then I also know that this guy plus this guy is actually the length of this vector here, right? That this one and this one counteract that one straight down, yeah? That'll be our expressions, okay? And so let's look at the x direction, right? These are the guys in the x direction. So in the x direction, we've got, I'm going to make this guy negative, so negative T2 cos 40 plus T3 cos 20. Those guys add up to what? That plus that adds up to 0. Right? And then let's look at it in the y direction. This will be in the y direction. This guy will be in the y direction. This will be in the y direction. Why? Because I love you. Okay. And even though nobody sees the Mickey Mouse Club show or whatever that is, it's still a funny joke. Okay, so I'm going to go positive T2 sine 40 plus T3 cosine 20 minus 122.625. Oh yeah, smart aleck kids. I did that just to test whether you were. Yeah, that one little mistake like that, and it's all over. Yeah.
So
Oh, why did I do that negative? Because it's to the left here. This guy's pointing to the left, that guy's pointing to the right. Yeah. And then this doesn't look like much fun to solve, does it? I don't see anything here that's going to help us except for just solving it, right? Okay. So we can, what I'm going to do is I'm going to rewrite this way. That's the same thing, isn't it? The forces up equal the forces down. In fact, in my mind, I set them up that way because that makes more sense than saying that they equal 0, right? Are we okay with that? And the reason I did that is that now we are all ready to, we can represent this system of equations as this matrix, right? And that's the matrix that, yeah? Okay. Here's, I'll call this guy B here. So what do we have? We have negative cos 40, right? Cos 20, sine 40, sine 20, T2, T3 equals 0 and 122.625. So there's what, 3 ways to solve it. We could do some sort of linear combination and eliminate something like that. We could substitute, which is what I used to show, but I'm way too lazy to do that if your calculators will do matrices for you, right? The only way you choose matrices is that you don't have to actually solve them and invert them, yes? Okay. And so I think this is correct. Isn't this correct? So the way that you know these guys here, notice that when you set up your equations, always put the things with T2 on one side, all the things with T3 on the other side, yeah? Okay. And then this side is the T2 side, the T3 side, and then when the answer matrix is made, it's like this. And I've patented this. It goes shloop. See that? It's kind of like a shloop kind of a thing, right? So the T3 falls down first and is at the bottom. Yeah? Yeah? I'm really not a very good mathematician, so I have to resort to silly things, right? And then, of course, the answer, this matrix here, the answer matrix will be, this guy here is going to be A inverse B. Yeah? So bust out your calculators. How do you do your matrices? Well, I'm just going to show you. Okay? Virtual TI. There we go. We'll just try that. All right. So take your calculator and let's see. I think we want to go second matrix. Yeah? There it is. So second, and then it's the x to the -1 button, at least on this one. Right? So go into matrix. And the first thing we're going to want to do is that we're going to want to edit a matrix. And mine is already set up because we've been solving 3 by 3 matrices. Okay? So I'm going to go across here. You click over to edit, and then A is the first one we're going to edit. It's already on A. Okay? So you just hit enter. And the first thing it asks you is what kind of matrix is it? And you want to say that it's a 2, enter, 2, enter. Okay? A 2 by 2 matrix. Are we good so far? A 2 enter, 2 enter. Right? And then now we're in the upper left-hand corner, and we want this to be negative cosine of 40. Don't we? Enter. I think I'm in, am I?